Moving on to the other problems, you can see here you have the problem is Q matrix. What is Q matrix? When you take a transpose, it is minus of the original matrix. So this is your Q matrix. You can see how when does this happen? When the diagonal elements here, the diagonal elements we have taken it as 0. And if I take a transpose of this, I'll be getting 0 minus A minus B. So if I multiply it with a minus, I will get back my original matrix, right? So this is the definition of Q matrix. So in the 3 cross 3 case, y is determinant minus k, that is determinant of k, minus k if I am taking, y is equals to minus 1 raised to 3 determinant of k. On the other hand, determinant k transpose equals to determinant k, always you know that determinant k is equals to determinant k from the properties of a determinant. Decide that determinant must be, deduce that the determinant must be 0. So you have to deduce that the determinant must be 0 from the property that determinant k transpose equals to determinant k. So for the first part of the question, y is determinant minus k equals to minus 1 raised to determinant k. So you can get it that if K is a 3 cross 3 matrix and using rule 3, that is determinant depends linearly on each of its row, we can have determinant minus K equals to minus 1 times of determinant K. Here we have K, if I am taking, if I want, that is if I take a transpose, so it will be equal to minus 1, and if I am multiplying it with a minus 1, so you are having that minus 1 is multiplied to all the k's, right? So this minus 1 is multiplied to all the 3 rows. So if I am going to calculate that taking minus 1 separately, I have 3 rows. So minus 1 raised to m, that is 3, right? From the third, this one, minus k. If it is just k, you assume that you have the determinant of k, and if it is minus k, so all minus 1 is being multiplied to all the 3 rows, and that minus 1 I have to represent it as minus 1 raised to 3. So according to that rule, we can see the determinant k minus k is equal to minus 1 raised to 3 determinant k, as k is 3 cross 3 matrix. And you have to now using this try to get deduce the matrix from this also. From that is, we know that determinant k transpose is equal to determinant k from one of the property of matrix, and you know that from the Q matrix is k transpose is equal to minus k. So taking transpose on both sorry, determinant on both sides, determinant of k transpose should be equal to determinant of minus k, and we know that determinant of minus k is minus 1 raised to 3 determinant k. So this gives you minus 1 minus of determinant k. So if I am taking the other right left hand side, right hand side to the other side, that is it becomes minus k. If I am taking this to the other side of the equation, what I will get, I will be getting it as determinant k plus determinant k equals to 0, that is 2 times of determinant k equals to 0, automatically becomes determinant k is equals to 0, right? So you have deduced from this expression, you have deduced that determinant k is equals to 0. And the next problem is Q matrix. You have to construct a Q matrix 4 cross 4 with the determinant not equals to 0. This the previous problem what they had shown is the determinant is equals to 0, and try to get a Q matrix whose determinant is not equals to 0. So here the diagonal one, the previous problem you could see that here we had one of the elements in the diagonal was 0. This is the skew matrix diagonal. The other diagonal I am talking about is in this diagonal. One of the element is 0. So automatically what happens? Your determinant product becomes 0. And so I'll try to take an example where the determinant is not equals to, the diagonal value is not equals to 0. So you can check here the diagonal elements plus 1 minus 1 minus 1. You can see k transpose. If I take k transpose and multiply it with minus 1, I will get back my original k. And you see the diagonal values are plus 1, all are non-zero elements. So automatically the determinant will not be equals to 0. So you can write any other this one also example. So you can find out the determinant and check it will be equals to 1, the product of the diagonal matrix. Just you have to arrange the rows and then apply the rule. Next is next problem asked here is find that is find these 4 by 4 determinants by Gaussian elimination. Find the determinant of this. So apply any of the row elimination method. So just one illustration has been done here. What I have done, I have subtracted the R1 from R2 and R4, R3 from R4. You can do the other way also. It's not compulsory that you have to do this. Even you can subtract the R3 from R3 from R1. If I subtract, if I change R3 minus R1 and R4 as R4 minus R2, I'll be dealing with what instead of 10, I'll be getting it as 20, 20, 20. That is 31 minus 11, I'll be getting 20, and 41 minus 21, I'll be getting 20. So this is one of the option of solution. You can do the other way around. So if I do that, you can see here, you are getting two rows with the similar values. So automatically according to the rule of determinants, if two rows are similar, you can have the determinant becomes equals to 0, right? Or you can, if you there itself you can stop, and or you can, if I proceed here, what I am doing, I am subtracting row 2 from row 4 from R2, row R4 from R2, so I am getting 0. So another rule is that if you are subtracting, if one of the row is equals to 0, then also the determinant is equals to 0. So if you are proceeding further also, it gives you the result that is determinant is equals to 0. So another problem you can look here. The inverse of a 2 by 2 matrix seems to have the determinant equals to 1. So you have a determinant 2 cross 2 matrix whose determinant is equals to 1. So they are asking you that determinant A inverse should be equal to determinant. A inverse is what? Just substituted the A inverse. If it is a 2 cross 2 matrix, you can write it easily as the determinant value, that is 1 divided by AD minus BC, and just changing the diagonal elements AB, and if the signs of the other diagonal elements changes here. Right. So according to this, can I write it as what is the determinant of this matrix? AD minus of minus B minus C, it becomes AD minus BC and AD minus BC. Is this right or wrong? That is being asked here. You can check here. This multiplication actually is for whole of the matrix, even for this whole of the rows. AD, and this is actually, it means what? D divided by AD minus BC according to A inverse in this formula holds as, and minus B divided by AD minus BC minus C divided by AD minus C. So both the rows it is being. So when you are taking an inverse, it is not AD minus BC. It becomes what? 1 divided by AD minus BC raised to 2, because 1 for this row and 1 for this row. This is a scalar quantity, 1 by AD minus BC. B is being multiplied with 1 by AD minus BC, and also for the second row it is being multiplied. So it will not be this denominator this will not be AD minus BC, it will be square. So that is the actual correction that has to be made. You can see here what is the wrong with that calculation I told you, and what is the correct determinant. Here I will show you that you have A can be written like this according to the formula of inverse, and if I am taking a determinant on both sides, so I tell A 1 divided by AD minus B is a scalar quantity. It is applicable to both the rows of the matrix, even this row and even this row. So when I find the determinant being multiplied with the scalar value, so that value becomes both the this one I will be taking both rows. So this scalar raised to 2 according to the rule. So rule 3. So it becomes square, and just find out the determinant of D A. I have written determinant, so I have the square matrix. Otherwise, you can write it as just the parallel lines in between D minus B minus C A. What will be the determinant of that? That is AD minus BC. So what will be the answer for determinant of A inverse for this? It will be equals to 1 divided by AD minus BC. So this is the correction that has to be done. So this completes the subpart of determinants and the problems on the properties of the determinants. I will give you an assignment. Just solve that assignment, and we'll move on to the next topic.